there's often situations where you need to know the size of some entity in your program. And when that happens, C has the sizeof operator that we can use. Now, there are some confusing details about how sizeof works, and so we'll cover some of those in this video, and then in a later video, we'll talk about how this works with pointers. So the sizeof operator returns the size of a data type. So we'll say size t and then pass a type in. Now the value returned from this operator is the memory space allocated to that particular thing at compile time. The parameter can also be an expression, and technically it's not a parameter because since sizeof is an operator, it's more accurately called an operand. Another thing to consider is that when we have structs, the byte padding of the structure is included in the size. And much like a lot of what goes on with sizeof, that byte padding is implementation specific. And it's important to remember that the C standard states some minimum sizes for some of the data types, but in general, the compiler is free to allocate more than that minimum amount of memory. So what you see me get as a result in this example, which will be running in Ubuntu under Windows 10, in some cases, you may see different results if you have a computer that has a larger or smaller word size in memory. And so don't get too hung up on the exact results because they may vary depending on your compiler and in your system. So here we have a C program that has 4 variables declared. We have a integer variable that we initialized to 10, a character variable that we initialized with the character literal A. We have an integer array with 10 integers, and we have a character array that we're using as a string, and we initialize it with the string literal C sizes. So let's use sizeof to determine how much memory is allocated for these variables. So for each of these variables, we're going to first print the value of the variable, then the size of the variable, and sizeof returns a unsigned long or a size t, so we need to use the unsigned long here. So we'll say int var and then sizeof int var. And just to be sure that that much is working, let's compile our code. And we have some unused variables, that's okay. And when we run this, we see that the size of the int variable is 4 bytes, so 32 bits. And I'm missing an underscore here. Now notice we didn't have to use parentheses here. This is an operator. And so the parentheses here would be optional. So now let's try the character variable. We'll compile, we'll run, and you can see that the character variable has a value of 65 and it's 1 byte. And that makes sense. If we want this to be the character output, we can just change this to a C. So let's do that. And we compile and run, you can see that it's the letter A. So now let's do the integer array. So we've done the same thing we did above, except now we use the array. Here we don't really want to print it, so let's just print index 0. We don't really want to print the whole array. And you can see that the first element is 1, but notice the sizeof is 40. And you may say, now hold on a second, there's 10 elements in this array, but keep in mind sizeof returns how much memory is allocated. So there's 4 bytes per integer and there's 10 integers. 10 times 4 is 40. And finally, let's do this for the string, which is just a character array. So we compile and it didn't like this. So we'll print that whole string. We'll print it as a string. So now the string variable is C sizes. So that's 1, 2, 3, 4, 5, 6, 7 characters. But notice the size is 8. And the reason for that is the string literal has an implicit null at the end. We have an index for each character plus that null at the end. So 7 characters plus the null gives us 8 total characters. Each character is 1 byte, so we have 8 bytes total. So we can also use the sizeof type to find out how much memory is allocated for a type, so a variable of that type. So here we'll say printf sizeof int. And when I compile this, I'm going to get an error. And the reason is it's expected an expression before int. So int isn't a name of a variable, it's a type. So here we actually need to put this in parentheses because this isn't a variable, it's a type. And so the type goes in parentheses. Think of it as it's like a cast. Let's do this for several variables. We'll do it for a short and a long. We'll do it for a float and a double. Let's also do this for a character. If I run this now, you can see I forgot my new lines. So let me add those. And when I compile and run, you can see my int is 4 bytes, a short is 2 bytes, a long is 8 bytes, a character is 1 byte, a float is 4 bytes, and a double is 8 bytes. And just to clean up the output a little bit, I'll put a new line here. So one final thing to see is I can look at the size of different literals. And I'll say size of some integer is equal to some size. And we'll just give the value 42 here, and we'll say size of 42. So let's do a character literal, and let's do a string literal, and let's do a floating point literal. So for my character literal, I'll just use A. For my string literal, I'll use the string with A in it. I think that'll be interesting to see what happens here. And for my float, I'll say 4.2. So let's compile this and run. Before we do this, pause the video and think what you expect each of these sizes to be. And I need to put an extra space here, but 42 is 4 bytes, A is 4 bytes, the string A is 2 bytes, and 4.2 is 8 bytes. So this is a double, since doubles are 8 bytes. This is 4 bytes because integers are 4 bytes. But this is the one that's confusing. So let's be a little more explicit what we say here. So let's put this in quotes, and let's put this in double quotes, and I'll need to escape the double quote character so that that shows up in my output as opposed to ending the string. So let me compile again and run. So notice the string A is fewer bytes than the character A. Now why is that? Well, this is 2 bytes because A is 1 byte, null is 1 byte, 1 plus 1 is 2 bytes for this string. But this character literals are actually integers, and so they have an integer value. And if we try to print this as a integer, it would not give us any sort of problem at all. And just to prove that, I'll do that last here. And when I run this, you can see that if I print this as an int, it gives me 65, which is the ASCII value of 10. So character literals are actually integer values, and I can use them as integers in my code. I can put those in a char variable because the integer value of a character literal is never going to exceed what could be stored in a character. So just a little bit of an idiosyncrasy that may be a little bit confusing, but if you just keep in mind that that literal is an int, but I can store it in a character because its value will always be small enough that I can store it in 1 byte, that might help it make a little more sense. So this is a quick introduction to the size of operator in C.